Okay, so we're going to go ahead and start our new chapter in math. You're almost done with this book. That's great. You're doing pretty good. The only thing is there's some skills that you can do them, but for some reason you think you can't. So anyway, we're going to start with this lesson. We're going to finish this chapter this week. So I don't care what happens, finish it this week. Okay? I'm going to try to do videos so that I can help you through it. Okay, so this is just follow the lines. It's on page 325 in your book. Alright, so though the earth is round, or at least somewhat pear-shaped, it's shown flat on a map. Maps often include lines to mark distance for people who travel by plane or boat. Latitude is a created measure that marks in degrees how far north or south a location is. Latitude is shown on a map as horizontal parallel lines that run east to west. I'm going the other direction. These are. Remember that because latitude is like fat, lat and fat, and they go around. The equator, which is the line centered between the North Pole and the South Pole, marks 0 degrees latitude. The starting point for north and south measurements on a map or a globe, that's where you start. So if it's 35 degrees south, you know that it's below the equator on a map. If it's 58 degrees north, you know that it's above it. So anytime it's degrees north, then you're going to look up. If it's degrees south, you look below the equator. Now, longitude lines or meridians are similar. These lines are the ones that run north to south, that is from the North Pole to the South Pole. They mark in degrees how far east or west something is on the Earth. The Royal Observatory, Greenwich, is on the prime meridian in London, making 0 degrees longitude, the reference point for east and west measurement. So the prime meridian works the same way as for east and west as the equator does for north and south. The directions on a compass are generally shown the same way on every map. You move north as you move up a map. South, move Romeo, south as you move down a map, east as you move right on a map, and west as you go left on a map. Okay, this should not be new to you. You've done this before. All right, so let's look at exercise 1 on page 326. All right, so clocks and time zones of the world, all right? Can you imagine a world without a way to tell time? Imagine the confusion. In our last lesson, we learned about shapes and angles. We also learned how to measure angles with a protractor. We learned that a right angle is 90 degrees and it looks like this. It's right there on your page. Okay, it's a right angle. We can see that 90 degrees is 1/4 of a whole circle. Romeo, quit! 90 degrees is 1/4 of a whole circle. A whole circle is 360 degrees. Look at that circle there on your page. Okay, they got the whole circle. Okay, now if you go all the way around it, that's 360 degrees because look what they did. They drew a line straight down the middle like the diameter, okay, and then another diameter straight across. So they did one like the equator and one like the prime meridian. Okay, it's like taking a pizza. What's the first thing you do? Well, you cut a prime meridian and then you cut an equator and you've got 4 big slices. Okay, 4 quarters. Okay, each one of those is a quarter of the pizza. Okay, but look at what kind of angle it makes when you do that. It makes a perfect right angle and there are 4 of them. So 90 times 4 gives you 360. I hope that makes sense. All right, so since our Earth is roughly a sphere, which is a 3D circular shape like a ball, we can divide it up into 360 degrees. Since there are 24 hours in a day, we can divide those 360 degrees by 24, which is 15 degrees. So you take 360, because there's 360 degrees in a sphere, okay? Divide that by how many hours in a day, which is 24, and you get 15. Now, these lines of longitude also mark time zones around the world. These time zones reflect how the Earth rotates from the west to the east 15 degrees per hour. So where do the degrees start being counted? In the mid-1800s, an English astronomer, George Biddell Airy, established the Royal Observatory in Greenwich, England. This location, what is that? Oh, this location, where was I? I lost my spot. Became the 0 degree, the prime meridian. If you'd like to learn more about the establishment of the prime meridian, lines of longitude, and time zones, here are some topics you could explore. What is the transit circle? How do astronomers chart the stars as they pass over the transit circle? So, how many hours are in a day? 24. How many minutes are in an hour? 60. How many seconds are in a minute? 60. Okay, those were things that you should have known. All right, so now the rest of the pages, the next 2 pages, there's 20 problems. I would really like to grade this page because this is all review, mixed review. I'm going to look through it and find the one or ones that you might have trouble with, and I'll help you with those right quick. Okay? Now, also remember, before you come to me or just put your pencil down, I couldn't do it, look back. Look back in your book at the other things that we've done, okay, before you give up on it. Now, on number 4, the top of page 327, what time is it at your location? Okay, you know how to tell time on an analog clock, okay, just little hand points to the hour, big hand points to the minute, okay. Now it says, look at your globe or your world map, choose 3 locations around the world, write them and their times here. Okay, so that, I'm not sure how we would do that because we haven't really learned time zones just yet. I mean, it's not hard, but like, I don't think we have a time zone map. Look at your globe or your world map. I don't think that one over there has anything on it. Wonder if I could find something. Let me find something. Let me just look at this. Time zone map. We want one for the world. Okay. This one might be a good one. Yeah. Okay, this is good. All right, so all these things, you see these degrees up here? Here's 0. Here's your prime meridian. All right, now these are all your degrees. And notice how they go up 15, 15, 15, 15, 15. They're going up 15, okay, because that has to do with time zones. These up here have to do with time zones too. So I'm not sure how we can tell. So we're in this one. This is our time zone. So whatever time it is right now. Let's look at this one. Easy time zone map. This one might be easier to tell. Oh, yeah. Yeah. Okay. This one's a good one. This one tells how, if you either add or subtract hours. Okay. So right here, so basically this is where we're going to start. So whatever time it is right now, maybe it's 11 o'clock a.m. right now. I don't know, whatever time it is that you're doing math. Okay. So you could choose, say, somewhere over here in Australia, Sydney. I don't know where Sydney's at, but maybe you could find out wherever Sydney's at. And so what you're going to do is you're going to add 8 hours. I think that's how you do it. Where you add, let's see, plus 8. Yeah. So this would be plus 8. Yeah, actually, and that's weird because, yeah. Oh, wow. Way up here in, I guess this would be Siberia, plus 12 hours. So like if it's, like I said, if it's 11 o'clock here and you chose Sydney, Australia, I think it's on this side of Australia, somewhere over here. So you'd add plus 10 hours. So 11, okay, 12 hours would be 11 p.m. So it would be 9 p.m. in Sydney right now. If it's 11 o'clock where we are, you just add the 10 hours. You add whatever it is. Okay. If you choose somewhere in Africa, then just choose where it's at, and then you just say, okay, plus 3 hours or plus whatever. I think that's right. That's how you do it. So anyway, but you might say, well, how do they know what to add and what to subtract? Well, it depends on where the location is on the world. It depends on the meridian where they are. And like this one is, you don't add anything. I don't know why. I know that, you know, you just, okay, now that's not right. No, that's not right, because if you go from where we live to, say, Florida, you don't subtract 5 hours. That's not how that works. Okay, so that's not right. And skip that. Too small. Well, I'm trying to figure out. Let me see. Okay. Oh, I got it. Okay, yeah, okay. I remember now. Okay, so yeah, you're not going to add 10 hours. Maybe you do add 10 hours. But like right here, if you go from here to here, that's just a 1 point difference. So 6 minus 5 would be 1. So it would just be 1 hour. So here you would say minus 6 or negative 6 plus 10. So that would be 4. The difference would be 4. I'm not sure. Why don't you do this? Why don't you do this? I don't know why I didn't think about this in the first place. You probably did, and you're like, Mom, why don't you do this? On A, B, and C, just ask Google. Say, Google, what time is it in? And just name 3 places in the world, anywhere. Look at the map. Jot them down, the name of the place and what time it is, and just ask Google. And that way you'll see, and you'll be able to see, you know, whatever it is. There may be a time zone thing on the tablet or something, or on my phone. You can find that. So just do that. Just find 3 places and ask Google what time it is right now in those places. Okay, number 5, number 6, number 7, 8, 9, and 10. Okay, those are all addition, subtraction, and multiplication. Okay, addition, everything has to line up just right perfect. Subtraction, you know how to do subtraction. Now, don't forget multiplication. Okay, this is super important. This is something you got to know. Remember, you just if you just take, like, say, 1387, this is number 9, times 622. Remember how we do it? Basically, we just pretend like this is not here and just multiply. This would be 14, carry your 1. This would be 16 plus 1 is 17, carry your 1. 2 times 3 is 6 plus 1, which is 7. 2 times 1 is 2. Bam, we're done with this one. Add a 0. Now you start on this one. And you do the same thing. When you get done, add them all up. Okay? I figured you remembered how to do that, but I'm just making sure. All right. 9 and 10 are the same. Okay, 11. Just go slow. Just go slow. You know how to divide. Just move slowly. Think about it, okay? It does say use your calculator to check problem 11. Remember, take your answer up at the top, your quotient, multiply that by the number on the outside, the 1, 2, 3, and then add your remainder. And you should get the number inside the box. If you don't, redo it. Get it right. All right, look at the next page. Number 13. You're going to round that number to the nearest blah, blah. All right, so I know you have trouble on these, but these are very important. Okay, 632,591,013. Now, it says the first one, round to the nearest 10. Okay, none of these are decimals. These are all just whole numbers. The nearest 10. What number's in the tenths place? Okay, all right. So that means all these will stay, all these numbers will be the same. The only numbers that will change are the last 2. The next one says round to the nearest 100. That means these numbers will change. All the rest stay the same. Okay? And then the next one says round to the nearest 1,000. That means these will change. Okay? Then it says to the nearest 10,000. That means these will change. All these will change to whatever it's going to be. These will stay the same. And then to the next one is to the nearest 100,000. Okay, that means that these will change. All these. These will not. Okay, always just the place that it says to round it to, look at that spot. Look at the next number to the right of it. And then that number to the right of it tells whether this number stays the same or goes up. Okay? I want you to do that yourself. I know you can. All right, and then numbers 14, 15, and 16. Draw an example of a sphere. That'd be like a volleyball. A pyramid, a rectangular solid. That would be like a book or a box or something to that effect. All right, number 17, 2/5 as a decimal. Remember, when you have a fraction and you need a decimal, you divide. That's 2 divided by 5. That means 2 is in the box. 6.2 as a percent per 100. Move the decimal 2 places to the right. Bam, you've got your decimal, or you've got your percent. Then you've got 620%. Write that as a reduced mixed number. Do that one on your own. And then number 20, you know how to multiply decimals. Now, how you do on these pages is going to let me know if you are ready. This is a review, okay? All right, now, when you are finished, get the teacher book and check everything today. Not tomorrow, not tonight, not next week, today. I don't care when it is or what you have to do. I don't care if you have to take it with us to wherever we're going. Check your answers today and then put it on my desk. Okay? If you don't know how to do it, go back and look. All right? All right, that's all for today.